Hello, and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Debbie Carboni.
Well, thank you, William. And I'm very excited today to present to you a case study on stencil printing optimization, optimizing the under-stencil fluid delivery settings for superior SMT printing results. So today I am going to talk about how out of all the chemicals on your manufacturing floor, the under-stencil solvents are probably the most misunderstood. There is a couple facts that we need to understand about stencil cleaning solvents. The printing process is only as good as the material one uses. Another fact is that if you do have a defect, there are absolutely no downstream processes that can fix it. And contrary to popular belief, how fast chemistry dries does not match the SPI data in the results that you'll receive by picking the right chemistry. Not only that, more is not better, but also IPA is actually a terrible solvent, and SPI data actually proves that. Nanocoatings is also something that absolutely will improve your cleaning process or your printing process, I should say, but you still need to have an under-stencil solvent that is engineered to give you the best results possible. Because as you see here, you can still have a nanocoating, and with the wrong solvent or with no solvent, you don't get as good of results as you do with an engineered solvent. The other fact is that, contrary to popular belief, your IPA is not the cheapest solvent for your process. So the opportunity that was given to KYZEN was by a global EMS company building automotive boards, predominantly charge port controllers as well as audio amplifiers. As you can imagine, the volumes were pretty high. They also use a well-known MPM printer, Momentum Type 2, and they also are using indium solder paste 10.8 HF, which is commonly used in the industry. They're right now only able to print 4 prints in between their wipe processes. And this is really driven by their 0201 board components that are the smallest components that they're processing today. They actually gave us 3 goals. And as a result of those 3 goals, KYZEN recommended our KYZEN E5631J. It should be noted that currently, this same customer does remove their stencils every 4 hours to clean them offline. And that's important because they also wanted to have a chemistry that was able to be used in both. So the 3 objectives that KYZEN was given is, one, it needed to be a safer chemistry. As you know, IPA is extremely flammable, and it does present some safety issues from using it inside your printer. In fact, actually, most manufacturing companies of printers actually will void your warranty if you use it because there is the potential risk of fire. The second objective we were given is to reduce costs. And by doing that, they were seeing a high rate of defects. The third objective was to reduce waste. And what they were looking at from that point of view is the amount of fluid that they were using, but also the cost of the wiping paper, as well as the amount of solvent that they were using. So as we moved forward, we looked at the safety comparison just side by side. As you can see here, you have great performance from a reflowed solder paste as well as adhesives should they need to use that. You will also notice that the flash point of the IPA is 54 degrees Fahrenheit, whereas the water-based chemistry does not have any flash point. It should also be noted that there is no toxicity, and this can be actually stored and transported without having to worry about hazardous conditions. The other nice advantage is that it does come in a ready-to-use formula. So with this comparison, we met the first objective of offering a safer and more environmentally friendly chemistry. So when we looked at the process, we took and assessed the board. They gave us a board that was very complex, actually, and they were running these in the MPM printer, as shown here. We needed to first clean out and purge the IPA from the reservoir, and we did this by following three simple steps. First is you're going to need to drain the IPA from the reservoir and refill that with 5631. The second, or I should say the third, is to manually pump the 5631J through the hose until the bubbles disappear, as shown in this video here. Notice the little bubbles. The second was we looked at the cleaning process parameters. And what you'll notice is that for this test, we did not change any of the solvent rod velocity or the paper speed or the solvent wetting speed. What we actually did was just simply change the number of prints we did between wipes. We went from 4 prints to 6 prints to see how effective we were without changing any of the process settings outside of that. That was a bonus for us because what we saw was excellent results. Not only did we see excellent results with an increased of number of prints, but we also saw that defect rate go from 24 down to 2. And as a result of that, the yields increased from 98.77% to 99.93%, which made the customer ecstatic. Well, this also met their second objective. In conclusion, after 1 week of using the 5631J, significant reduction of both defects and yields allowed them to process their system with having excellent results. They went from using an IPA wipe with their nanocoating to a solvent wipe with their nanocoating, and they achieved all three of these objectives: a safer chemistry, higher yields, reduced defects, and reduced waste. They were using less paper, less chemistry, and had to do less rework. A win-win. Not only that, but the KYZEN team is also working to further optimize and reduce costs. When we look at cost versus efficiency, you look at the IPA and you naturally look at the fact that it is a lower cost per container. But when you calculate and take into consideration the volume of solvent that's actually used and evaporated off using IPA, you will see about a 1.5 or 2.5 times reduction in the amount of solvent that is actually being used in the process. As a result of that, you basically have apples to apples in a comparison for the cost of the solvent, whether it's IPA or an engineered chemistry. And as a result of that, you get to see huge cost benefits in your overall cost of printing. When we look at the cost savings examples, you will see that by putting in the numbers that this customer achieved, they actually were looking at an annual cost reduction of a little over $11,000. That's using a chemistry that was more than double the cost of IPA that they were paying. They did that by improving their efficiency and reducing their defects. So we have a couple of frequently asked questions that I wanted to share with you. And the first question that comes to mind is, why does a vacuum always improve your yields in your printing recipe? The reality is we've done quite a bit of research in this area, and we've seen when you end in a dry wipe, you're actually pushing those solder balls back up into the apertures, causing you to have potential defects and also lowering the number of prints that you're able to achieve. The second question that we have is, can a coating improve yields without engineered solvents? Well, yes, they can improve the yields, but they're not going to do away with them. What we have seen time and time again, and we see it in the SPI data, is that by using a nano coating and by using an engineered solvent, you can take out some of the variation in your process and you see more consistency between your wipes. Another question is do you adjust the solvent volume for each solvent? Actually, this is a very good question. And what we are going to be working with this EMS company with is actually doing just that. By optimizing and setting up your solvent and the type of paper that you're using, you can further optimize your whole process and maybe even improve and increase the number of prints between wipes by doing this. So how come IPA cost is more than engineered solvents? Well, that is actually a very good question and something that very few people understand. The reality is that IPA actually evaporates at such a quick rate, and depending on how that fluid delivery system is, it may have an open trough, which allows it that extra material to be exposed to the air, and it's evaporating off and it needs to maintain a certain level. So that is one way that it's going to add to your cost. The second way that it adds to your cost is it takes more material to get you even a somewhat acceptable wipe. And what you will also find is that often you actually see the flux smeared on the bottom side of the stencil itself. We have several papers that if you're interested in learning more about, we'd love to talk with you. And I believe that that is all of my time today. I want to thank you for joining me, and I hope to hear from you with your questions.
Thank you, Debbie. And thank you all for watching this Tech to Tech session. If you'd like to discuss this topic further or have any questions not answered in the session, please contact your local KaiZen regional manager or send an email to tech@kaizen.com. And we will have someone follow up with you as soon as possible. To download the case study this session was based on, click the link in the description below. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who'd benefit from these sessions? If the answer is yes, just go to tech2tech.kaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.